All right, Honors Chem, today we are going to learn how to balance redox equations. Now, it's a little bit different and it's a lot more involved than just balancing normal chemical equations. We are going to use the skills that we use to balance normal chemical equations, plus we're going to add on oxidation numbers that we just learned how to do, and figuring out where the electrons go. So we're going to have to not only balance the elements, but now we're going to also have to balance the electrons. So let's start with some ground rules first, and then we'll do a few to help you understand what's going on. Okay, so here are our ground rules. Balancing redox equations. There are many methods for balancing redox equations. So this is not the only one. This is what is called whole cell, as in WHOE, like the whole entire cell method. A lot of chemists will also do half cell. So if this whole cell method that I'm teaching you is kind of confusing to you, feel free to look at half cell videos, or I'm happy to teach you half cell if you would rather try something else, okay? But I like whole cell better, okay? It's been developed over many years, and hopefully it's been perfected. Okay, step one, step one is always assign oxidation numbers to each element in the reaction, okay? So we always want to start out by assigning the oxidation numbers, and you probably, hopefully, are feeling comfortable doing that. Next, you need to check what changes. So there's going to be two elements, one that's oxidized, one that is reduced. So you need to see which elements are changing between the reactant side and the product side. Those are the elements that you are really going to pay attention to for the next bit. Step two, balance the atoms that change oxidation states. So you need to make sure that those atoms are balanced before you balance any other atoms. This step is often not required because the atoms that change oxidation state are often already balanced, but sometimes they're not. So make sure that they're balanced first. Then you need to see how many electrons are being lost and gained, and you need to balance the electrons. Okay, so step three, balance lost electrons with the gained electrons. Okay, that usually is done next. And then number four, sometimes it's necessary to balance non-reacting elements that are not hydrogen or oxygen. So this is where you go in and balance the non-hydrogen and non-oxygen elements, okay? This is pretty unusual, but one of our examples will have this in this, and you'll see this, okay? Then you have to look at the charge. You're gonna compare the charge between the reactants and the products. And you need to make sure that they have the same charge, because charge has to be balanced as well. So if we have an acidic solution, we are going to use hydrogen ions to balance. If we have a basic solution, we are going to use hydroxide ions. Okay? So we are going to use positive hydrogen ions to balance if it's an acidic solution, or we are going to use negative hydroxide ions to balance if it's a basic solution, to get those charges to be equal. Okay? If unsure, if it's not known, we always assume acidic solution. Okay? So if it's not stated, or if you're unsure, just use acid. Step six, then you're going to balance all hydrogen atoms in the equation with water molecules. Okay, so if you have any hydrogens, you're going to balance them with water. And then step seven, you're going to check your oxygens. Your oxygens should balance. If they don't, that means you have made a mistake somewhere along the way, and it's best, honestly, to just start over. Okay? So if these steps are followed carefully, any and all redox equations can be balanced. Okay, and this will take some skill. So hopefully by the time you're done with this, you'll get the hang of it. Okay, so let's start with some examples. We're going to balance the following redox equations. So the very first thing always is what is rule number one or step number one? It is to assign oxidation numbers. Okay, so let's take a second and assign oxidation numbers. If you want to pause the video and put those in and then check in just a sec, then you can. Okay, so here we have a 0, we have a +1. I'm going to make this bigger. We have a +5, we have a -2, we have a +2, we have a +5, we have a -2 on the oxygens, we have a +4 and a -2, +1 for the hydrogens, and a -2. Now, all of these oxidation numbers are for the individual atoms, okay, not the overall charge. Okay, how'd you do on that? Okay, the next thing that we've got to do is we've got to look at, see what is changing. So what has changed? Notice we have hydrogen, or not hydrogen, we have nitrogen going from a 5 to a 4, but not all of it did. So this one's going to be kind of tricky, okay? And we have copper going from a 0 to a 2, okay? So those are the ones that we are going to focus on. Now, step 3, are they balanced? I have this 1 copper and 1 copper, and we're only going to pay attention to the nitrogens that are changing right now. So this nitrogen here in the copper nitrate, we're going to ignore. I've got 1 nitrogen and 1 nitrogen. So I'm going to ignore this other nitrogen here on the copper nitrate. So they're balanced for now. Okay, now we have to look at the electrons. So we need to see how many are coming and going, and we need to balance them. So let's start with our copper. How do I go from a 0 to +2 using just electrons? Remember, Leo goes Ger. So losing electrons is oxidizing. So copper loses 2 electrons. So copper's oxidized here. So I have 2 electrons lost here. Okay? And for the nitrogen, I'm going from a 5 to a 4. So that means I've gained 1 electron. So I have 1 electron gained. Okay? Now, I've got to balance this. I can't lose 2 and only gain 1. The same amount of electrons has to be flowing back and forth. So I need to balance those. So I need to multiply this all by 2 to get me 2 electrons. So I'm going to multiply my nitrogens, everything that has nitrogen that is changing, by 2. Okay? So now I have balanced my electrons that are coming and going. Next, I need to balance the non-hydrogen, non-oxygen atoms. And that happens to just be nitrogen. Okay? So here I've already got 2 nitrogens, but I've got 2 nitrogens in this NO3. So I need to give myself 2 more nitrogens. So on my reactant side, so this 2 is going to go to a 4. Now my nitrogens are all balanced. Okay, now I need to start looking at my hydrogens. Okay, so because I don't have any charges here at all, so I don't have to really balance charges. So let's look at my hydrogens. I've got 4 hydrogens here, so I need 4 over here. So I need to multiply my waters by 2. So if I do all of this, my oxygen should balance. So 4 times 3 gives me 12 oxygens over here. I've got 6 oxygens here. I've got 4 oxygens here plus 2 more. gives me 12 oxygens here. Okay? So that, if you need to watch that again, take it step by step. Feel free, because there's a lot of moving parts to balance these. Okay, let's do the next one. We have hydrochloric acid plus nitric acid going to HOCl and NO, nitrogen monoxide, and water. So first things first, we are going to assign oxidation states. So here we go. +1, -1, +1, +5, -2. Now this one's kind of weird. So which is the most electronegative element here? Is it oxygen or is it chlorine? It's oxygen. So oxygen is a -2. Hydrogen is a +1. Chlorine here is a +1. This is a weird one. So be careful. Make sure you look at what is the most electronegative. Okay? Nitrogen here is a +2, oxygen here is a -2, hydrogen is a +1, and oxygen is a -2. Okay? How'd you do on assigning oxidation states? Okay, now what is changing? What is changing their oxidation state? Nitrogen is changing its oxidation state, and chlorine is changing its oxidation state. Okay? So do I have the same number of chlorines on both sides of the equation? Yes. So that's balanced. Do I have the same number of nitrogens? Yes. Those are balanced. Okay, now we're going to look at the electrons. How many are coming and going? So remember, Leo goes Ger. Okay, so nitrogen is going from a 5 to a 2. How do I do that with electrons? I have to gain 3 electrons, right? So 3 electrons are gained. So nitrogen is reduced here. And chlorine goes from a -1 to a +1. So 2 electrons are lost. So chlorine is oxidized here. Now, how do I get 2s to match 3s? I need to look at my least common multiple between 2 and 3, and that happens to be 6. So what do I have to multiply 2 by to get 6? I need to multiply it by 3. So I'm going to multiply everything that has the chlorine in it by 3. And what do I need to multiply 3 by to get 6? I need to multiply it by 2. So I'm going to multiply everything that has a nitrogen in it by 2. Okay, so that balances my electrons. I have 6 coming and 6 going. Okay, so next thing I have to do is look for anything that is not hydrogen or oxygen that isn't already balanced. And I don't have anything. So that's good. I don't need to do any charges because nothing's charged here either. So now I need to look at my hydrogens. So my hydrogens on my reactant side, I've got 3 plus 2, that gives me 5. And here I have 3 plus 2, that also gives me 5. Okay, so if I've done everything correctly, my oxygen should balance. So 2 times 3 will give me 6 oxygens here. I've got 3 here, plus 2 more here, plus 1, and that gives me 6 for my oxygens. Okay, so we're balanced. All right, this next one, we're going to do a little bit. So take some time, put in those oxidation states, and check it in just a minute. Okay, you ready to check? So tin here is a +4, chlorine's a -1, iron's a 0, tin here is a +2, chlorine's a -1, and iron here is a +3, and chlorine's a -1. Okay, how'd you do? Did you get the correct oxidation states? All right, so next thing we've got to do, what is changing? So tin is changing and iron is changing. Okay, so those are the ones that we're going to look at. So do I have the same number of tin on both sides? Yeah, 1. Do I have the same number of iron on both sides? Yes, I do. Okay, so now we're going to look at the electrons coming and going. So with tin, how do I go from a +4 to a +2? I have to gain 2 electrons. Okay, so tin is being reduced. And iron, how do I go from a 0 to a +3? I lose 3 electrons. Okay, so once again, we need to find our least common multiple between 2 and 3, and that happens to be 6. Okay, so what do I need to multiply 2 by to get 6? 3. So everything with tin is going to multiply by 3. And what do I need to multiply 3 by to get 6? 2. So everything with iron is going to be multiplied by 2. So now I have the same amount of electrons coming and going, 6. Okay? So, do I have other non-hydrogen or oxygen things to balance? Yeah, I need to make sure that my chlorines are balanced. So I have 3 times 4, which gives me 12 chlorines. 3 times 2 gives me 6, and 3 times 2 gives me 6. So 12 equals 6 plus 6. So we're good. We don't even have to worry about oxygen or hydrogen on this one. So this one's a pretty easy one. All right, so here we go. This one, we start throwing in charges. And this one is in acidic solution. So we're going to balance using hydrogen plus ones. Okay? Our very first thing we need to do is put in our oxidation states. So take a minute, put in your oxidation states, and check it in a sec. Okay, you ready? So oxygen is a -2. So that means if this has to add up to a -1, that means the chlorine has to be a +7. Okay? Bromide is already a -1. It's already labeled here, and chloride is already labeled a -1, and bromine elemental is 0. Okay? So what is changing here? Chlorine is changing from a +7 to a -1, and bromide is changing to bromine from a -1 to a 0. Okay? Now, this one does have us balance. So I've got 1 chlorine and 1 chlorine. I've got 1 bromine and 2 bromines. So I actually have to balance this before I even look at the electrons. Okay? Now we're going to look at the electrons. Okay? So, chlorine. I go from a 7 to a -1. What do I do to get from a +7 to a -1? I gain 8 electrons, right? 8 electrons are gained. Okay, now think of this. We are dealing with not 1 bromine, but 2. So each bromine atom is going from a -1 to a 0, which is losing 1 electron, but we've got 2 of them. So we are really losing 2 electrons. Okay, so we need to be mindful of that. 2 electrons is what is being lost. And yay, my computer is having a nice little fit here. So hopefully this won't take too long. So we're losing 2 electrons on the bromine. Okay, so while we're thinking of that, our least common multiple between 2 and 8 is 8. So we're going to have to multiply all our bromines by 4 to give us 8 electrons. So we'll give the computer just a minute to think about this. If it takes longer than a bit, I will stop and start a new video.